And now, how can you be able to have the energy content in a certain given energy level, and also the energy difference between two energy levels in which the electron moves from up to? Let's say we have a typical atomic structure. Let's say this is a typical atomic structure where this is the nucleus that contains proton and neutrons. Let's say that is the case. And outside the nucleus, we have the energy levels. Let's say this is energy level number 1, and let's say we have sort of another energy level, I'll call it as energy level 2. Let's say that is the case, and we have the another energy level, let's say given as energy 3, up to energy level 3, and I'll call it as N is equal to, let's say, 3. Now the point of interest is that we would like to determine the amount of energy contained in the first energy level, and let's say the amount of energy contained in the second energy level, and also third energy level, and also even the amount of energy contained in a specific given energy level. How should we have that? So we use what we call as the Rydberg's equation. Rydberg's equation states that the energy content in a specific energy level is given as the negative RH, and which is 1 over energy level square. So this is what we call as the Rydberg equation, and of which RH is said to be Rydberg's constant. It is given as RH is equal to 2.18, and times 10 to the power negative 18 after the joules. So this is what we call as the Rydberg's constant, and this is what we call as the Rydberg's equation. And here's the question for you: why should we have negative? Why is it that on the Rydberg's equation we do have negative? What is the insertion for this negative sign? So I want to see the correct responses in the comment section below, if you can have to do that. So which means in whichever the actual energy level of interest, let's say energy level 10, 15, whatever, we can be able to have the energy within that particular energy level by using actually this formula, which is the Rydberg's constant, Rydberg's equation. And this is what we get as the Rydberg constant. So keep that in mind. And also in the same case, let's say electron is moving from lower energy level to, let's say, upper energy level. And for that case, this is initial energy level, and this is the final. I'll call it as the final energy level. And there is the energy difference between the two energy levels, since the energy level 1 has got its own actual energy, and the energy level 2 has got its own energy. If that is the case, now what is the change in the energy between the two energy levels, if that is the case? So now the energy level difference will be given as, change in the energy, which is equal to, have it as RH, which is Rydberg's constant, times 1 over initial actual energy level square minus 1 over final energy level square will be given as that. And this is a formula used whenever we are having the energy difference between two energy levels. So keep that in mind. And basically you have to understand that this change in the energy level is also the same as, change in the energy level is also equal to HV. Now this is a Planck's quantum theory, and which is equal to this. So which means in all cases you have to understand that the change in the energy level between two energy levels is given as the change in energy is equal to HV, which is now according to the Planck's quantum theory, and is equal to RH in times 1 over initial energy level square, and minus the final energy level square. So we'll have it as that. So which means if we have the change in the energy, we can be able to have, let's say, the frequency and also even the wavelength using the same principle. So that's how you start to understand that one. And let's have the following questions and appreciate how we can have it. And now let's say this is the question: what is the wavelength of a photon emitted? So we are looking for the wavelength which is given as lambda, and that during a transition from, we have the initial energy level, that is 5, and we have the final energy level which is given as 2, and like that. So how should you have the wavelength? So you start to understand that, so since there is a change in the actual energy levels, according to what occurred as the Planck's quantum theories, the change in the energy level, the change in the energy is given as the Planck's constant times the frequency, and of which, using the Rydberg's equation, this is the same as having it as RH, 1 over initial actual energy level square minus 1 over the final energy level square. So which means the first thing, we should have to calculate the change in the energy by using this formula, and upon having the energy difference, then you'll be able to have the frequency, because if we have the energy, we'll have it here, then we'll have it as the energy difference is equal to HV. Then we'll be able to solve for actually frequency. Upon having the frequency, we know that the frequency is given as the speed of light divided by the wavelength. So this is how we should have. And let's say this is the question: what is the wavelength? We are looking for the wavelength, which is lambda, and we have the initial energy level, which is 6, and we have the final energy level, which is given as 4. We should have the wavelength as well. According to the principle behind, the change in the energy is equal to HV, which is the same as the Rydberg's constant times 1 over initial energy level square minus 1 over the final energy level square. And from there you can be able to have the wavelength using the formula frequency, speed of light divided by the wavelength. So this is how you should have to understand about actually what occurred as Rydberg's equation, and how you can have the change in the energy between two energy levels, and also how you can have the specific energy in a given energy level. So that's how you start to understand it. So which means you can also be able to have the energy contained in the following energy level. Let's say energy level 6, so try to have that, and let's say energy level, then try to have the energy using the Rydberg's equation. Let's say energy level 2, have the energy, and also try to have the energy difference as a particle moves from, let's say, energy level 1 to, let's say from N1 to, let's say, N3. Try to have the energy level difference, and let's say we should have the particle moving from, let's say, energy level 5, let's say, to energy level 10. Try to have that one. And what if a particle moves from energy level, let's say, 4 to energy level 8? So try to have this. So that's how you start to understand about the Rydberg's equation that is being used to find the energy contained in a specific energy level, and also difference in the energy in the two energy levels. Thank you.